All right, this is chapter 6.3 on solving systems of linear equations by elimination. So the first thing I want you to do is go ahead and write these 4 steps down. These are the 4 steps that you need to solve a system of equations by elimination. So go ahead and pause it, write these down. All right, now that you have those written down, we're going to do an example here. So we've got 2 equations and 2 unknowns. 3x minus 4y equals 10 and x plus 4y equals negative 2. So the first step, write the system so that like terms are aligned. So I'm going to rewrite these right down here. There's my step 1. Pretty easy. Now, step 2, eliminate one of the variables and solve for the other variable. To do this, to eliminate one of the variables, I'm going to add these 2 equations together. So 3x plus x ends up equaling 4x. Negative 4y plus 4y, well, that's just 0. That's what you want. You want one of those variables to essentially go away. You want them to add together to equal 0, because then we've eliminated one of them. So now I've got equals, and 10 minus 2 ends up being 8, which is wonderful because now instead of 2 equations with 2 unknowns, I've got 1 equation with only 1 unknown. 4x equals 8. So I can divide both sides by 4. 4 divided by 4 is just 1x. 8 divided by 4 is 2. I've solved for my variable. X equals 2. So I'm halfway done. That was step 2. Step 3, substitute the value of the variable into one of the original equations and solve for the other variable. So you get to pick one of the 2 original equations. I'm going to pick the second one just because it looks a little bit easier. There's less numbers to worry about. So I've got x plus 4y equals negative 2. Now I know what x is. X equals 2. I just figured that out. So instead of x in this equation, I'm going to go ahead and substitute 2 in for x. So instead of x plus 4y, I'm going to have 2 plus 4y equals negative 2. All right. Now I can solve for y. Minus 2 minus 2. Those are 2's, believe it or not. 4y ends up equaling a negative 4. Negative 2 minus 2 is negative 4. Can divide both sides by 4 again. 4 divided by 4 just equals 1y. And negative 4 divided by 4 is negative 1. So step 3, I have substituted and solved for the other variable. The final step, step 4, I have to write them as an ordered pair, x then y. So x comes first, x is 2. Y comes second, y is negative 1. And there's my final answer. 2, negative 1 is the solution for this system of equations. Okay, so that was pretty easy. Well, easy is maybe the wrong word, but it worked fairly well. We added them together, we eliminated a variable, but we're going to try a few harder ones here. So here I've got the same idea. I've got 2 equations, 2 unknowns. So they're already pretty much written right above each other with the variables lined up. So I'm not going to have to do step 1. It's pretty much done for me. However, step 2, I'm going to add these 2 together. 3x minus 2x is x. 3y plus 3y is 6y. And 15 minus 5 is 10. And now I've got a problem. I tried to eliminate one of these variables, and I still have both x and y. If you run into this problem, if when you add them together, you don't eliminate one of the variables, you're going to have to change some things. You're going to have to manipulate this problem to make it work the way we want it to. So I'm going to do that. I'm going to rewrite the problem with my variables lined up. I'll show you why in a second. To do this, I want either the x's to subtract and go away, or I want the y's to subtract and go away. And the easiest way to do this is if I take that second equation and I multiply it by negative 1. And I'll show you what I mean in a second and how this works. I could have picked either one of these 2. I picked the second one. If I distribute through the parentheses here, remember you have to multiply everything by negative 1. I end up with 3x plus 3y equals 15. I didn't change that first equation. And negative 1 times a negative 2 is a positive 2x. Negative 1 times a positive 3y is minus 3y. And negative 1 times negative 5 is a positive 5. And what that ended up doing for me is when I add these together, 3x plus 2x ends up equaling 5x. 3y minus 3y, well, that's 0. Now I've eliminated one of my variables. So by multiplying by negative 1, I've changed that second equation. I've manipulated it so that I could eliminate those y variables. Equals 15 plus 5 ends up equaling 20. Now I can solve for x. So I divide both sides by 5, and x ends up equaling 4. Okay. So I know what x is. Now I'm going to take one of those two original equations. Both of them are about equally as difficult. Nothing easy about either one. So I'm going to say 3x plus 3y equals 15. Now I know what x is now. X equals 4. So I'm going to substitute that in. And 3 times 4 plus 3y ends up equaling 15. 3 times 4 is just 12 plus 3y equals 15. Can subtract 12 from both sides. 3y ends up equaling 3, which is really nice because when I divide both sides by 3, running out of room here, y ends up equaling 1. So now I know what x is, I know what y is, I can write my ordered pair for my solution, x then y. The solution for this ordered, or for this system of linear equations is 4, 1. Okay. Let's try another one here. So I'm going to look right away, see if they work without me changing anything. If I add these two equations together, 2x plus 3y ends up, 2x plus 3x ends up equaling 5x. Negative y plus 3y is 2y, and 7 minus 3 is 4. So as a quick check, when I add these together, they don't quite work. They don't eliminate the variables. So I can't just leave it alone. So I'm going to have to change these a little bit. So I'm going to do that by, well, first I'm going to rewrite them. There we go. So the easiest way to do this is I want one of these two to subtract away. And it's hard to explain without looking at an example. So if I take that first equation here and I multiply it by 3. If I take that first equation, multiply it by 3, and I distribute through here, 3 times 2x is 6x. 3 times negative y is negative 3y. And 7 times 3 is 21. So when I distribute through, I get something that looks like this. And that's great, because I have a minus 3y and a plus 3y. That will end up being 0. So I've changed the problem. I've manipulated. I've tried to put a square hole in a circular hole, or a square block in a circle hole. And we've changed things so that it will work. So if I add these together now, 6x plus 3x ends up being 9x. Negative 3y plus y is 0. And 21 minus 3 ends up being 18. One equation, one unknown. I can solve for x, divide both sides by 9, and x ends up equaling 2. Halfway done. Now I just have to pick one of the two equations. I'm going to pick the second one, just because. So I've got 3x plus y, or excuse me, 3x plus 3y equals a negative 3. I know what x is now. X is 2. So I'm going to substitute that in. 3 times 2 plus 3y equals negative 3. 3 times 2 is 6. Plus 3y equals negative 3. I can subtract 6 from both sides. End up with 3y equals negative 9. And so I divide both sides by 3. Y ends up equaling negative 3. So I found x, I found y, I can write my final answer as an ordered pair x, 2, y, negative 3. So I'm using that elimination method to eliminate one of the variables. Last one here, 5x plus 2y equals 11, and 6x minus 3y equals negative 3. Again, for this, you're going to have to change some stuff. It doesn't quite match the way we want it to. And this is probably one of the harder ones that you're going to have to worry about, is when there's no nice, easy way to do it. For this one, we're going to have to multiply both equations by something. And if you don't see an easy way to answer your question, if there's no variable all by itself, we're going to have to multiply by something. So I am going to pick the y's to worry about, because I want to eliminate the y's. The reason I'm picking the y's is because I already have a plus and a minus. And that's really nice. I want to leave that alone. So I'm going to do this. I'm going to multiply both the first and the second equation. Multiply the top equation by 3, the bottom equation by 2. It's kind of like finding a common denominator. You got to have something in common. And since 2 and 3 aren't easily converted into something, you have to multiply them both. If I distribute through, I'll have 15x plus 6x equals 33. And 12x minus 6y equals negative 6. Which again, worked out really slick, because now I have a 6y and a minus 6y. So those will eliminate themselves. And that's what we're looking for. So I'm going to add these together. 15x plus 12x ends up being 27x. 6y minus 6y, 0. They eliminate themselves. 33 minus 6 ends up being 27. Divide both sides by 27. And x ends up equaling 1. Again, I have to pick one of the two original equations. I guess I'm going to pick the first one. At this point, it doesn't really matter which one you choose. Neither one is going to be any easier than the other. So 5x plus 2y equals 11. I know that x equals 1. So 5 times 1 plus 2y equals 11. 5 times 1 is just 5. Plus 2y equals 11. Subtract 5 from both sides. So 2y ends up equaling 6. You can divide both sides by 2. And y equals 3. So I've solved for x, I've solved for y. My final answer again, an ordered pair, x, then y. And I have my solution. These take practice. You really have to be able to look and see, okay, how do I want to eliminate one of these variables? What's going to be the easiest way? And it takes a lot of practice. So, all right, good luck.